Today, we're diving into Pydantic AI. If you're an engineer or an architect building with large language models, knowing Python and agent development is a number one skill to have. The most sought-after professionals right now, with the highest salaries, are those who can build reliable, production-grade AI agents. But the agent framework space is moving extremely fast. It feels like a new tool launches every week, making it hard for most developers to find a framework that they can actually trust for serious applications. I've used dozens of agent frameworks, and one of them stood out to me in how smooth and developer-friendly it was. It's Pydantic AI. I will show you a complete flight booking agent and connect it with the observability framework called Logfire. Watch this video till the end to see an exclusive and candid interview with the creator of Pydantic himself, Samuel Colvin. I asked him why he's jumping into the crowded agent framework wars now and what Pydantic is doing fundamentally different from the existing tools. We get into a frank discussion about what Pydantic AI's killer feature is beyond just type safety. We also explore his thoughts for making high-stakes technical decisions like the rewrite of Pydantic and Rust, and we'll hear his main prediction for 2026. Stay tuned to see an example of Pydantic AI as one of the most intuitive agent frameworks and to hear from Samuel Colvin, one of the most important minds in Python ecosystem. Pydantic AI is a Python agent framework designed with one simple aim: to make building production-grade applications with AI less painful. Think about how FastAPI revolutionized web development. It offered an innovative and ergonomic design, all built on the foundation of Pydantic. Virtually every agent framework in Python today uses Pydantic, and the team behind it felt that developer-friendly feeling was missing when they started building with LLMs themselves. So they built Pydantic AI to bring that FastAPI feeling to AI app development. It's completely model agnostic, supporting OpenAI, Anthropic, Gemini, Grok, and Mistral with a simple interface to add others. And it seamlessly integrates with Pydantic Logfire for real-time debugging, monitoring, and tracking. The design is Python-centric. It leverages Python's familiar control flow, so you can apply standard best practices just like any other project. Being type-safe is a core design principle, making your code as powerful and informative as possible. It also is based on the power of Pydantic to validate and structure model outputs and ensures your responses are always consistent. For more advanced work, it offers an optional dependency injection system, which is useful for testing and eval-driven development. It provides the ability to stream LLM responses with immediate validation, giving you real-time access to the outputs. For complex applications, Pydantic Graph provides a powerful way to define graphs using simple type hints. Let's go straight into an example, and I will explain it step by step as we go. First, we're going to install Pydantic. Then dive into the flight booking agent code. In my cursor terminal, I am using UV to initialize a new project. Then I'm adding a Pydantic AI package. We will also be trying an observability library called Logfire that can be easily integrated with Pydantic AI, so we're adding it too. The next step is to add Pydantic examples. To make sure they're added to our local examples directory, we run this UV command. We can check that indeed all the files we need are now accessible within the directory. At this step, make sure that you have your environment variable for OpenAI API key to set your API key before running the code. We're going to run the Pydantic model example to check that it works. It does. Now, let's test the flight booking agent. It calls the search agent and uses extract flights tool. It found a flight and is asking us if we want to buy it. We say buy. Then it asks for which seat we want. Let's say a window seat. It booked us a seat 1A. Now let's check our observability data through Logfire. Ensure it's installed, that you have an account, and that you put the Logfire token in the configuration settings. In the terminal, we authenticate with Logfire, indicate our region, and proceed to open a Logfire web page, which completes the auth process. Then we create a new Logfire project with the name that we want to give it, which returns a project URL, where we'll be seeing the metrics. We're ready to run the flights example again. We buy the flight the agent is proposing. This time, let's ask for a specific seat, like 2B. And it got us this seat. Now let's go to the Logfire dashboard to see what kind of insight it provides. We go into our project and select the right timeline. We see a couple of events, search agent run and seat preference agent run. And we can look deeper within what's happening. We see that search agent used GPT-4o and used one tool called extract flights, which in turn used an extraction agent, which also used 4o and found us 8 flights. It also shows us how many input and output tokens were sent back and forth at each step and their cost. We can see the payload for each call. This is the one about the flights. When we get into the seat preference agent, we see that the user asked for seat 2B. Now let's get back to Cursor and look deeper into the code that makes this work. First, let's look at the imports. We're bringing in standard libraries like datetime, but also key components from Pydantic and, of course, Pydantic AI itself. You will notice Logfire and Rich Prompt. Logfire is for advanced logging and observability, allowing us to see exactly what the agents are doing under the hood. Rich is a library for creating beautiful, user-friendly command line interfaces, which we use here to ask the user for input. Next, we see this line. This automatically sets up Logfire to trace the execution of Pydantic AI agents. It gives us detailed step-by-step view of the agent's reasoning, tool calls, and retries without us having to manually add logging statements everywhere, so it's fantastic for debugging and understanding agent behavior. Now, let's look at our data structures. We have the flight details Pydantic model. By defining flight details as a Pydantic model, we're creating a contract with our AI. We're telling it, the information you give me must look like this. This gives us predictable, structured data. We also use a field description to give the AI model extra context about what a specific field represents that improves its accuracy. We also have a depths class. This is for dependencies. It's a clean way to bundle all the external information that our agent needs to do its job. So instead of passing multiple arguments to the agent, we pass this single depths object. It contains the raw text from the web page and the user's original request details. This keeps our function calls tidy and organized. Now, for the core application, the agents, we have our main orchestrator, the search agent. Its job is to manage the flow and find the cheapest flight that meets the user's criteria. Then we have the extraction agent. This is a key design principle here, the separation of concerns. The search agent handles the high-level goal, while the extraction agent has one specific task: to read the text and pull out all the possible flights. This makes our system more modular and reliable. The search agent uses extraction agent through a tool. Tools are how we give agents capabilities. The search agent knows from its prompt that it needs to find flights. It sees this tool whose description says, "Get details of all flights," and intelligently decides to call it. The context or run context object is important here. It's how we access dependencies like context, depth, web page text from the tool. After the agent finds the flight, the output validator acts as the safety net. LLMs can hallucinate or make small mistakes, and this function is our programmatic check. If the agent returns a flight that doesn't match the user requested date, for example, we raise model retry. This sends feedback directly to the agent, telling it, "You made a mistake, here are the details, now try again." This self-correction loop is incredibly powerful. Then we define two more Pydantic models: seat preference and failed. Just like with the flight details, this is all about creating a structured contract with our AI. When we ask for a seat, we don't want a random string. We want a seat preference object with a row that we can validate is within a real range. The failed model gives us a clean, predictable way for the agent to say, "I couldn't do this," which is much better than saying "return nothing." Next, we finalize our third agent, the seat preference agent. The key reason for having this agent is specialization. Let's look at its systems prompt. It's loaded with the specific context about the seats, which ones are windows, which rows have extra legroom. This is knowledge that the search agent doesn't need. By creating a specialized agent, we keep our concerns separate. Each agent is an expert in its one task, which makes the whole system more powerful and easier to manage. Then we have this large text block, flights web page. This is our mock data. In real application, you would fetch from a live website. The reason that we hard-coded here is to make the example self-contained and reproducible. It ensures that anyone who runs this code gets the exact same result without depending on the internet connection or the website that might change. So it provides a stable input for our extraction agent to work with. And then we define our usage limits. This is a critical safety rail. API calls to LLMs cost money, and this line acts as a circuit breaker, ensuring that our app doesn't get stuck in a loop and make thousands of requests by mistake. It's an essential piece for building responsible, production-ready AI applications where you need to control costs and prevent abuse. And the main function brings it all together in a while true loop, because finding a flight is often a conversation. The user might not like the first option. The loop allows the back and forth. And if the user wants to search again, we package up the message history and feed it back to the agent. It gives the agent memory, ensuring that it doesn't suggest the same flight again twice. Finally, once the user decides to buy, we can call two helper functions, find seat and buy tickets. The find seat function uses the third agent, the seat preference agent, in its own loop to understand the user's seating request. Again, this is a specialized agent whose only job is to translate phrases like a window seat up front into a structured seat preference object. And buy tickets is our final action. In a real application, this is where you would call a third-party API to complete the purchase. Here, it just prints the confirmation, showing that the structured flight details and seat preference objects have made it all the way to the end of our workflow. Now that you know what Pydantic AI is and how it works, let's hear an interview with Samuel Colvin, the creator of Pydantic, Pydantic AI, and Logfire. The current AI agent space reminds me a little bit of the JavaScript framework space in 2015, where there's just so many of them and everybody's pushing their own. Do you feel like we're going to converge on some patterns of philosophies?
I think it's very like the JavaScript world. I think that's a very good parallel. I think that if you look at the JavaScript frameworks that won out, they came out 10 to 15 years after the web settled. AI has not yet settled, and we are definitely not even a year after it sort of started to settle, let alone 15 years. So I think it's very likely that a lot of the stuff that we're designing now and saying is definitely right will look pretty dumb in 15 years' time. I suspect that the reactive AI hasn't been invented yet, although we have an agent framework. I think we're doing things differently, but I think it is quite early to assume that. I think the thing that if you speak to people, someone like this, who have a lot of deep experience, a lot of people are relatively cynical about agent frameworks. I think they've been bitten by the poor engineering of some of the earlier ones. But I think what people do want is the model agnosticism and the capacity to go and switch model easily. So that's why in Pydantic AI, sure, we have the agents and the high-level abstractions, but we also have the direct API where you can go and build as if you were using one of the SDKs directly, but still switch model in one line of code.
You created a very popular framework, just Pydantic, right? And it's used by many other companies already. So a lot of these companies have their own agent frameworks, but you created your Pydantic AI agent framework. So what was fundamentally wrong with other frameworks that convinced you that I need to create my option?
There's a bunch of subjective things that are my opinion, that I can give my opinion on why I don't like them. I don't want to be too rude about other people who've gone and built open source, but I can say what I don't agree about them. I think objectively, I think the number one difference is the importance we have put on type safety and building things in type-safe ways for reasons I've already explained. I don't think anyone else has tried to do that in Python as hard as we have. In some places, that even makes it slower to develop, but I think it will make it easier long-term to go and refactor. It's definitely been a lot of work on our side. It would be very easy to be like, oh, well, everyone gets what we're trying to do here. Just put a type ignore and move on. We've worked hard to make it type-safe because we think that's important. That's the most obvious objective difference. The other thing I think you can say without going and being specifically rude about the other frameworks is look at the team of people who are working on Pydantic AI and the breadth of experience they have building open source. So I have maintained Pydantic since 2017. It has had 5-6 billion downloads. I think it's had more downloads than well, I was going to use the example of Gangnam Style. I think it's just overtaken Gangnam Style's views in terms of downloads. But then Marcelo is maintaining it with us. He maintains Starlet and UV-Acorn, basically the core networking stack in Python now. David Montague, who maintains it with me, he's also maintained Pydantic along the way and Pydantic Core with me over the last few years. Dower was running an open source company before he did this. Like, this is not us taking the junior developers or the interns and being like, go do open source. This is the most important thing. Not the most important thing we're doing, but like one of the most important things we're working on, and we're putting real engineering effort into trying to do it right.
In general, how are you thinking about framework differentiation with AI making it much easier to copy somebody else's work? For example, with Logfire, it's kind of built on top of OpenTelemetry. But do you think that there may be a world where a competing startup could recreate it and make it better and win?
Talking about Logfire specifically, no, I don't think there is. Right? As in, sure, there is open source we built on. We're very public. We use Data Fusion under the hood. Data Fusion is an excellent building block to go and build observability on, and that's the reason that even non-startups like Datadog are investing heavily in Data Fusion. So sure, the fact that there are open source building blocks makes it easier for people to come along and compete. But you give an AI agent any amount of resources and time, tell it to go and build an analytical database with distributed storage and compute where arbitrary users can write untrusted SQL and also manage the compaction of receiving data every second, and it will never succeed. So I don't think that like that level of engineering, there is no evidence that we're going to get to that level of engineering within the visible time horizon. I'm not saying it's never going to happen, but there is not evidence that it will happen.
When somebody is looking for an observability tooling, right?
Yep.
They probably also care about evals and guardrails and all of that. So if you're a developer who wants to choose between, Pydantic and things like weights and biases, what is your mindset, like model for making that choice?
I think that there are things you can obviously go and take a bet on, like OpenTelemetry. It is a well-regarded, I think, extremely good standard. Go and bet on OpenTelemetry. Go and say we're going to integrate with OpenTelemetry all the way down. You are not betting on one single company. In fact, you are betting on the opposite. You are betting on an open standard. That is why the web won out, even though there were lots of companies who wanted their own proprietary networking for e-commerce. The web won because we had an open standard, and that was what worked. And I think the same is true of OpenTelemetry. The same is true of Python type hints. So fundamentally, this is an open standard that everyone can go and build on. So I would say, go and choose an open standard to build on. Again, don't buy into libraries where you have to use the platform. PyTest would not be as ubiquitous as it was today if PyTest was built by a company who was saying you have to go and send your run your unit tests on PyTest Cloud. It is ubiquitous because it doesn't have that. Of course, we're a company, but we have not ever tried to change the license of Pydantic or force you to use anything paid on Pydantic. Pydantic evals are evals library. Again, it's trying to be the PyTest of evals in the sense that, sure, you can send the data over OpenTelemetry to view, and we have an OpenTelemetry platform. We would love you to use it and pay us, but you don't have to. And I'm confident that long-term open standards and collaboration are going to win out over siloing and walled gardens.
Between type hints and pattern matching and, your own framework, Python is evolving quite fast. Is there something that excites you in the future of Python or something that worries you?
I think that the stuff that is happening at Astral, UV, is making an enormous difference and is moving the dial. I'm really excited for TY to come out. I think that Python is moving faster than it has before. Annual minor releases are a big thing. I'm really excited about the Py03 work and the capacity to go and write Rust extensions to Python in Rust. That's obviously how Pydantic works under the hood. I'll admit to be biased. David Hewitt, my friend who works on us with Pydantic, also maintains Py03, but I think that's really exciting. I do think that there is a double-edged sword of UV, which is that because it's getting easier and easier to create more and more Python packages, we are going to get more Python packages, a denser and more complex, deeper SBOM than we have had in Python until now, and that's going to have disadvantages as well as UV having enormous advantages, right? So you install React, you get whatever it is, 672 dependencies. You install FastAPI, you get, I don't know the number, but 6 or 8 or 10. We are going to, 6 or 8 or 10 is probably going to balloon into 20 or 30 over the next 5 years because UV has made it easier to build more packages and have more packages installed in your virtual env.
In the V2 of Pydantic, you rewrote it in Rust, right? And it's a pretty big change. How do you go about making these hard technical choices? What's the framework?
I'd love to say there was some complex process. At the time, there wasn't a company. It was just me working on it on my own. I sat down one day out of curiosity. What would it look like? Could you even do this? 3 weeks later, I kind of came out of the kind of hole of working every hour of the day and was had the beginnings of a prototype, and I was hopelessly optimistic about how long it was going to take. So I thought I could do it in 3 months. 8 months later, I was halfway through, and thankfully Sequoia got in touch and invested, and then I was able to hire a team to work with me on it. But yeah, there was not... It's not a project that would have happened within either an enterprise, I think, or a VC-backed startup, because you would look at it and be like, is that really worth it? There are other profitable things we should go and do. Whereas as a solo individual making a little bit of money out of maintaining this open source, I was able to stubbornly just be going I'm going to work on this all the time because this is what I want to do.
On the business model side, developers know you most for the open source project, right? Did developers' opinion kind of change when you started having these potentially paid options, right? Did they push back and say, oh, we want more free stuff? Are you trying to push Logfire together with this? How did it change kind of your positioning of these tools?
I've been amazed by how little of that there has been. Sure, there have been a few voices on the edge being oh, I wouldn't trust Pydantic, now they're a company. I remember someone online said, "Oh, I wouldn't trust Pydantic or Rough anymore now that they're backed by companies." And the guy worked for the CTO's office at Google, and he got like roundly destroyed on Twitter, and ended up deleting his post. So, but he was a like very marginal, exceptional viewpoint. For the most part, people have been incredibly positive about it. Of course, interested to see what we're going to go and build. They have opinions on what's good and what's bad, but like I think also we've proved like we haven't tried to commercialize Pydantic directly at all. The other companies in the space doing similar things like Astral and like FastAPI, I think, are also giving people confidence that like these companies may succeed or fail, but like no one's going to go and like try and do the rug pull of like change the license on Pydantic or FastAPI and expect people to use it. It would just not work.
If you were restarting in tech from scratch right now, what would be your plan?
Oh God, I don't know. I don't think I have been particularly strategic in my career, and like I'm going to go and do that thing. I worked on oil rigs in Indonesia after university. I thought that was a fun adventure to go and do, and then found my way into tech. And often the things that I've been most lucky with in my career have happened through serendipity. So I didn't reach out to Sequoia to try and raise money for a company. I got this lovely email from Bogomil and you know, recommended by Sebastian. I didn't expect Pydantic to be successful. I made up the name in like 5 minutes and put it up on PyPI and was surprised, and was very surprised by what happened. Even though we were a VC-backed company thinking about what was going on, we were off building Logfire basically for the last 2 years, and everyone went and started using Pydantic for validating structured outputs without us pushing it. Obviously, it was the luckiest thing that happened to us as a company, but we didn't actually plan it or try to make it happen. It just happened naturally. And so I've been very lucky in that regard. But I also think that not always going and doing the obvious thing is valuable, right? I mean, if you wanted to go and build a commercial open source in 2017, the obvious thing to go and do was build a database, because databases have this lovely model where you can be like, it's open source, but we'll host it for you. And maybe I would have had success trying to build a database. But the fact is that like data validation library market was much more open, much less money being spent there. And so I was able to have success with Pydantic I probably wouldn't have had if I had been like, I'm going to go and build a database, for example.
What's your one prediction for 2026?
Oh, that's an interesting one. I think we will look back on the idea of writing non-type safe Python code at the end of 2026, like people currently look at anyone who's writing raw JavaScript where they could be writing TypeScript.
Now let's bring it all together. We moved beyond theory and built a practical, production-ready flight booking agent with Pydantic AI. We saw firsthand how its Python-centric design and smooth Logfire integration helps us create more reliable and observable applications. We also heard exclusive insights from the creator of Pydantic, Samuel Colvin, on his vision for the future of agents, his stories, thoughts on Python, and his predictions. The ability to build robust, observable, and production-grade AI systems is what separates regular engineers from the most in-demand, highest-paid engineers in the industry right now. The principles and tools we covered today are designed to give you the exact professional advantage. Make sure to like this video and subscribe to my channel. Thanks for watching, and I will see you in the next video.
Your reality has changed. You're stuck in your career. You're either using AI or being used. Do you still believe success is guaranteed? You feel it's time to wake up. Old strategies don't work anymore. Welcome to the real world. It will never be the same again. You need to fight for your future. Learn to spot truth from lies. I will help you. Together, we will win.